again. Hello everyone and welcome back to another edition of Index Office Hours. Today is the 16th of Jan and this is IOH 140. So for all of you who are new to Index Office Hours, this is the town square for graph ecosystem participants to come together and discuss the most important and relevant topic for indexers. This is a conversation. We love participation. So if you would like to get involved, please do via voice or text. And if you're having any challenges with your mic and trying to speak, let me know and I will try and get that sorted for you. As a reminder, this is a session that's going to be recorded and distributed onto public channels like YouTube. So if you're concerned about privacy, please bear that in mind. And with that, let's get into today's agenda. So the shout out as it relates to opening remarks is for 𝗨𝗂𝗧𝗂𝗧 podcast episode 151 with Martine. And Martine is the head of the 𝗨𝘀𝗲𝗂 Foundation. And we were fortunate enough to have one of his colleagues come over to IOH recently to share a bit about 𝗨𝘀𝗲𝗂 and what they're doing. So if you're interested to learn more about the chain, we're actually supporting the chain on the decentralized network. So maybe this could be an interesting way for you to learn a bit more about the network. And oh, there you go. There you go. Juan is back on it. I love it. Thanks for sharing the episode, Juan. Appreciate it. There you
Juan!
Go. Oh, that's great. It's great. Wow. Can somebody please add that to our graph soundboard? I would like to use that in future. That's a really good one. Thanks for sharing, Vince. Please do check out the yeah, we did miss you, Juan. It was nice to have you back, by the way. So thank you, my friend. Yeah, please do check out the 𝗨𝗂𝗧𝗂𝗧 episode that has been linked right there. Awesome. That is it for opening remarks. Now I will hand over to Anna for our regularly scheduled Repo Watch section.
Thank you, Abel, and hello, everyone. Okay, so today's Repo Watch is quite heavy, so I'll try to go fast so we can get to the file data service presentation. So, starting with execution layer client, we have had the new release of Aragon. This is 256.2. This release fixes Aragon's failure to stop gracefully that has been introduced in 256.0. We have tested this release on all of our testnets, like Ethereum, 𝗨𝘀𝗲𝗂𝗧𝗏, 𝗨𝘀𝗲𝗂𝗃, and also on Gnosis Caddo. Next, we have get two new releases, starting from the least recent one, so 1.13.9. This fixes a few issues and enables Cancun upgrade for the 𝗀𝗏 network that will be upgraded at tomorrow at 6:32 a.m. UTC. And if you're running 𝗀𝗏, this is a required update. However, they've also released version 1.13.10, which is the equivalent of 1.13.9, plus a version bump. And this is just because of a bad commit made it into the previous release. So please do upgrade to the latest get, so 1.13.10. Then on Firehose Ethereum, we have had release number 2.2.0. This adds support for EIP 4844, which is upcoming with the activation of Cancun fork, and adds new fields in the Ethereum block model so that the fields that will be non-empty when the Ethereum network you're pulling have EIP 4844 activated, and please check the release notes for all of those fields. There have been some updates onto the Substream server, so it fixes the error parsing between Tier 2 and Tier 1. Tier 1 will now schedule a single job on Tier 2, quickly ramping up to the requesting number of workers after 4 seconds of delay. And the error store became too big, is now considered a deterministic error and returns code invalid argument. All operators running 𝗀𝗏 chain will need to upgrade to this version that contains the get released 1.13.10. On Nethermind, we have a new release as well, 1.25.0, adds support for 𝗀𝗏 Denkum hard fork, And another big change here, the JSON.NET library was replaced with a system text JSON implementation. So as a result, the memory overhead was drastically reduced, and block processing time was improved as well. And in general, JSON RPC handling has been sped up. And then moving on to consensus layer client, we have a new release for Prism. This release is 4.2.0, strongly recommended for all operators to update as it has many bug fixes, security patches, and features that will improve the Prism experience on mainnet. Some things you need to know: this release increases the default peer count to 70 from 45. This is done so that the nodes running with default peer count can perform their validator duties, but you can, if you're not a validator, you can change that with the P2P max peers flag back to the what was before 45. For validators, please check the release notes because there are specific upgrading and downgrading notes about how to approach this release. On Teku, we have had release 24.1.0, a required update for anyone running girly nodes, an optional update for everyone else. This fixes an incompatibility between Teku validator clients and Lighthouse beacon nodes and fixes a block publishing endpoint issue where 202 status code could be returned, but the block hasn't been broadcast yet. Important note here is that Teku will require around 50 gigabytes of extra storage for blobs, but theoretically blob storage requirement can go up to 110 gigabytes. So yeah, be aware of that. Then on Lighthouse, we have a new release candidate, so 460 release candidate 0. All girly users must update their nodes by tomorrow 6 a.m. For the Dencum hard fork. There have been some extensive changes made to the networking components in this release. So focus has been on a number of performance and structural changes to the Gossip protocol and discovery mechanism. Important note here, you should not be running this pre-release on anything mainnet related, but you should on girly and for girly validators. On the graph stack, we have had a new release of indexer service and agent. This release is 0.21.1. It contains a lot of fixes, but I think we shouldn't go through them because we have tested it and right now it doesn't work. So indexer service just exits without any error logs, and we're able to confirm that with someone from Node as well. So even though there's a new release, please don't try it or don't update right now, as it's not fully working on indexer agent. And this is all I have. Indexer stack doesn't seem to build, is what Payne is saying, which is similar to what we've been observing. Handing over to you, Juan, unless there's
Juan!
Oh Jesus!
Did you cover the graph node release that was just announced? Like pre-release, sorry.
I think I missed that. Was it announced?
Like literally minutes ago before IOH.
Yes, okay. I will do that right now. Sorry for missing that.
No
okay, so graph node release version 0.34.0, release candidate 0. It adds substreams as a source of triggers for subgraphs, which significantly enhances subgraph functionality by enabling substreams to act as a source of triggers for running subgraph mappings. Indexer hint in manifest for automated pruning has been added. So introduces the ability for subgraph authors to specify indexer hints with a field prune in their manifest. Introducing initial StarkNet support for GraphNode, expanding in indexer capabilities to the StarkNet ecosystem. We have GraphIQL version 2 update. So GraphIQL query interface of GraphNode has been updated to version 2. Some metrics enhancements. Some bug fixes, so address the bug in the deduplication logic for Cosmos events, ensuring that all distinct events are properly indexed and handled. Fixes compatibility issues with Elasticsearch 8 and onwards. Resolves issues when rewinding data sources across multiple blocks. And resolves an issue when each call results for reverted calls were being cached in a call cache. Fixes a bug for Graphman index creation to ensure entire string and bytes column are indexed rather than just their prefixes. And a new Graphman deploy command has been introduced, which simplifies the process of deploying subgraphs to GraphNode. Thank you, Payne, for notifying about this. And yeah, any more comments?
Successfully running it in production.
Already? Wow, that was
Yeah.
great. I will be doing that sometime today, and we'll let you know.
Yeah, let's go.
By the end of AOH. All right, okay. Handing over to Juana.
Should we take a sec to have their comment on this? Unless I mistakenly read something in the comments that I misunderstood.
Yeah, I can shed a little bit of light on a couple of these things that were highlighted in the Discord post. Two of them specifically, just from a subgraph developer side, that's going to really improve the lives of indexers. Number 2 and number 4, 5 you won't really see much of a difference, but that is really handy for subgraph developers. But starting with number 2, so automated pruning, this is going to give subgraph developers the chance to state like, hey, I'm not going to time travel or run any time traveling queries on my subgraph. I've got no intent. Go ahead and prune that thing, to the max or whatever. And they'll be able to state like, yeah, prune it up to the most recent, to where you only keep the most recent 1,000 blocks worth of entities, right? And a really key distinction that a lot of people, forget when they talk about pruning is an entity can be created a year ago, but if it's not changed, that's still like a valid entity, right? That's current state. But if that entity has any type of a change, we insert a second record. So record number 1 becomes archive state. Record number 2 is now your current state. Pruning would only get rid of record number 1, even if you pruned it up to tomorrow, because you have to have all current state in your subgraph. But all that old stuff can only be accessed through time traveling queries. So giving the freedom to subgraph developers to say like, hey, I'm not going to do any time traveling queries. Go ahead and get rid of all of the archive state. It has the potential to just save a ton of storage on our end as indexers. On number 4, the end block feature in data sources is really nice, especially for subgraphs that might be deploying like a version 2 of their protocol, and they're like, great, version 1 is now deprecated. Let's go ahead and end that as a data source, because when the indexer is looking through all of the event logs to see like, okay, here's an event that I need to run a handler for. The more data sources that you have, the more it has to kind of search through that. So having only one data source is going to be very different than on Uniswap, which has tens of thousands of different pools in their factory contract and their non-fungible position manager, right? All those different things. It's just going to take longer for you to sift through all the event logs and say, okay, is there anything in this batch that I need to index? So having the ability to end those things and state like, hey, this is no longer relevant, will just make our indexing times a lot cleaner because we're not looking for things that don't exist at this point.
Yep, sounds great. It should improve performance, hopefully. But I think the major change would be the automatic pruning. That would probably be the most felt new feature for indexers, at least. The rest of them make sense for developers for the most part. But yes, thanks, Derek, for the small heads up and explanation. That's always super interesting. Cool. So getting into Protocol Watch, I'm going to try to make it brief so we can have all of the open discussion. First of all, we have 3 different new adding support for in forum governance. First of all, we have Scroll Mainnet, which is a ck-EVM compatible EVM compatible chain for L2, which they just created the thread, so we don't have any information on how to run it. But for the most part, at least there's a thread for it. Then we had add support for 𝗨𝗂 chain, which is a Gnosis chain testnet. It has a little bit of information on how to run it in some documentation. So if you're brave enough, go ahead. And then adding support for BEVM Canary, which is an EVM compliant Bitcoin L2 or something along those lines. I'm not entirely sure I understood it correctly, but yeah, that's pretty much it. For forum research, we have all of the core dev updates. As always, this includes GraphOps, Messari, Geo, Edge and Node, Streaming Fast, Pinax, Semiotic Labs, and the Guild. Again, those updates are pretty lengthy, so if you're interested in any of those teams or any of their major developments, all of the forum threads are linked in the agenda. Continuing with forum research, we have query blockchain data from multiple subgraphs with a single GraphQL operation. This is coming from GraphBase SDK, which apparently allows you to do just that, basically query the blockchain data from multiple subgraphs using a single GraphQL operation. I'm assuming this kind of like takes care of all of the merging of responses and stuff. Haven't tried it though, but there's a cool thread with an explanation and a blog post that will probably be useful for dApp developers. For the contracts repository, we have a ton of PRs, but for the most part, most of them are chore PRs to improve the testing capabilities, removing CLI from product contracts and stuff like that. We do have a few of them which are quite interesting, which is one of them is the Subgraph Availability Manager contract, which is kind of like the start of the decentralized SAO. And then we have 921, which is deploying GGPs 31, 34, and 35 to testnet. I think this includes the fix for the cooldown blocks as well as some other minor improvements. Again, it's going to go through testnet first, so no need to worry. For network subgraphs, we don't have any new releases yet, and that's pretty much it for Protocol Watch. So I'm going to hand it over to Paka for Project Watch, unless there's no content this week. I would assume there is.
You remembered, yay.
I've been training my whole vacation.
I love it. All right, Paka,
Well,
you ready?
I was hoping to you tease the graph node release during Project Watch, so I don't actually really have much content this week, so we can probably kick it back to Apple. Yeah, thanks.
Alrighty, the alpha has been leaked already. Okay, cool. So as many. Oh my God, Mike. That's the worst sound effect I've ever heard. It makes me feel so uncomfortable, dude. It's like it's so sexual. All right. So as many of you have already seen in the tweet that we've published from the IOH Twitter channel, we have the GraphOps team with us today, and we're very excited to share some new updates and collate a bunch of feedback. So 𝗨𝗂𝗧𝗪, I believe, is the right person to hand it to, unless there's someone else to hand it to. So 𝗨𝗪, do you want to take it away? Alrighty, Hope, take it away.
Hello, can you hear me?
Yes, loud and clear.
Okay, I will share my screen. Can people see my screen?
Yes, we can indeed. Thank you.
Okay. So today I'm going to talk about file hosting service. Some of you might have heard about this. We previously referred to this as file data service or subfile data service. Now we renamed it to file hosting service, even though naming is an ongoing process that might be changed later on. But for now, we think this is a good name. Yes. Okay. So what is file hosting service? This is a data service that has payment-enabled file sharing intended to launch as part of the Graph's world of data services. Our target user demographic is indexers, which is you guys. For the service, we are trying to formalize the indexing work sharing as a data service. And you can sort of imagine what this implies for other data services, such as subgraph, substrings, or SQL, that with any services that operate based on some sort of data set, this service is intended to reduce the redundant work done by different indexers, especially when some files has been accepted as the correct data set to operate on. And for anyone joining to make new data services available, this should lower the time to data and bootstrapping costs. Overall, we think it should increase market efficiency. Because we are focused on indexers specifically, we're splitting indexers into data producers and data consumers. For the producers, we imagine that these are the people with existing data sets. With that, they should be able to create additional revenue aside from the data services that they are already a part of. And we're trying to make it so that the service, running the service will not create much additional cost than what has been resourced to create the existing data sets themselves. And then on the other side, there is indexers as data consumers. These consumers is mostly aiming to bootstrap to a new service. So example would be they are trying to index a new subgraph or host a fire host chain. We're assuming that the speed to create these new services will then become the limitation of the network speed instead of the compute speed of creating the subgraphs or extracting data from the from blockchains. Also lower cost because as a consumer can buy or purchase a set of data from a producer, the cost becomes the price the producer prices to download rather than the actual indexing costs to compute index data. And some of the example data sets are Firehose files to sync up a Firehose chain, or a snapshot of subgraphs at a given height. So when a consumer purchases a subgraph snapshot, they can load the snapshot into their database and start serving from there. So at this point, I guess I can pause for questions a little bit. Do people have questions about the setup? Maybe ideas for other types of data sets, other use cases, or
Yeah, I
potential.
put one in the chat, but just I don't know exactly if this would fall under this type of a service or if it's more part of the Gossip Network or exactly how that would align, but is there an intent that subgraph developers will be able to publish subgraph manifests to the decentralized group of indexers rather than utilizing IPFS?
Yes, so that is a great question. That's also one of the use cases that we would like to support in the future. I know that a lot of subgraph developers are relying on a hosted IPFS gateway from Edge Node, and I know that there is motivation for us to move away from relying on the gateway. So it's entirely possible for this to be part of this service where this data producers will host these manifests as some kind of files or some type of data sets that they can provide to anyone who would like to query from. So I guess potential users aside from indexers will be whoever is interested in the manifest for, say, subgraphs or I guess other manifests for other data services. Yeah, in general, that's a great question. I think they have different qualities, but I think this is quite possible. The possibility. Okay. So I'll move on. So some of the basics, every file that is available via file hosting service will come with a corresponding file manifest. This manifest, similar to subgraph manifest, contains metadata describing the file and the hashes that describes or corresponds to the file content. This manifest is uploaded to IPFS and becomes content addressable. The file manifest CID is what's being used to be an identifier for the file when it's uploaded or downloaded from between producers and consumers. A general flow for the data consumer is they will send micropayments for a chunk of the file to data producers. So they will specify a byte range for a file. And once they receive the data from the data producer, they will hash the content and compare the hash against the file manifest in a way that allows it to be incrementally verifiable for the file content itself. On a higher level, aside from downloading and uploading individual files, we have a bundle manifest that allows multiple files to be downloaded at once. So it will refer to multiple file manifests and basically contains the metadata for the bundle and a list of file manifests CID. Okay, I guess a little bit more detail on the micro payments is that we're using Scalar Tap as the payment system. And the manifest, my personal opinion is still that we can abstract it away from IPFS, or like Chris said, we can move away to some other setup of IPFS. The detail on the hashing is we're using SHA-256, and also the manifest should be very minimal so that it is easily matched between data producers and data consumers. And here I have a list of assumptions that we made about our users. So for the data producers, we are thinking that they will be running a continual process similar to the current indexer service component. They will manage service units either through as bundles or individual files. They will provide reaccess to the service units through file storage or object storage. They will be publishing files or bundle manifests on IPFS and handles packaging of the data based on their local setup. For on-chain, they will register their indexer URL and manage allocations to be compatible with Protocol v1. And then they will access tab escrow subgraph for contract for verifiable payments. For the data consumers, they are responsible for identifying the IPFS hash of the manifest for which they would like to download. This is critical in having verifiable content of the file. They are responsible for maintaining a balance for making escrow deposits. Also, similar to the producer, they have to provide an output path with write access so that they can write the data they would like to download. Or optionally, the downloader can just standard out the data they receive from the producer. I see questions. So, different URL for file data service. Data source. I'm not sure if that's related, so I'll leave it to Juan. But other than that,
I think the question is whether the endpoint that the indexer registers on chain for service discovery purposes would be the same or different.
Yeah, I think the same. And it's funny it's funny that this question came along because it's something that actually came along in some internal discussions, and we don't really have an exact solution yet as to whether it's the same one. It might be path based, it might be different registered. There are pros and cons to each of those solutions, so yeah.
I think, well, at least I think it's possible if we are opening allocation to like a file that contains a different URL rather than what you have with subgraph queries. And we can do discovery a little bit differently, so it's still compatible with v1. Although I would agree that that's something that we can explore a little bit more on based on the use case. And then, yeah, again, wait for a little bit for any other questions or concerns about the assumptions we made.
Just make a quick comment, Hope, if that's okay. Jim here.
Yeah, sure.
Something that comes to mind is that one of the most prevalent use cases that sits outside the current sort of scope you've set is snapshots of various different types of nodes all the way down to archive nodes. So typically, you know, if you were to pick an example like Arbitrum, the Arbitrum Foundation provides snapshots of all different types for their Classic and their Nitro nodes, and they're very big. And there's a small group of people who want that, but it's a bigger group of people than just indexers. So I just wanted to make a comment really that it would be very useful. I don't know if it's, you know, increases the scope too much, but it would be very useful to open the possibility of providing those snapshots to not just indexers, but anybody who wants to pay for those snapshots. And it could, you know, in theory, that could be a paradigm shift for some of these foundations that are paying a lot of money to host these large snapshots, whereby maybe us indexers who have all of those snapshots, can get paid for providing them to other people. I feel like we need to keep that in mind, even at this early stage with this product, that there's a slightly wider scope of customers out there that we could try and capture early on. That was it.
Thank you for the comment. That's a great idea. We also had a conversation with Semiotic about EIP 4444, where they're proposing to have less requirement for what a full node would keep in their history, if I can recall correctly. So a place where file hosting service could play in here is for some indexers to keep full history, and basically provide the data whenever history that aren't kept in full nodes can be purchased whenever is necessary. So I agree that there is a wider scope, and like Juan said, files are files. And yeah, I think that's a great, it's good that you can see this from so early on. Okay, I guess I can move on from here. So here's a list of features that currently we support. We have CLI tooling to publish, download, and host files. We have something configurable to chunk and hash files to construct manifests. So this is part of the publisher. And then there is automatic chunk verification against manifests for both the downloader and the server. So the server, upon initialization, they would do verification of their local data against the manifest they would like to be available for. There is content addressable identification of the manifest through IPFS. Then there is, for the downloader, there is availability check and basic suggestions for when there is no availability for other type of files to download. And the downloader also tracks indexer file availability and indexer block list whenever there is a chunk that wasn't served or failed to verify. The downloader also has randomized concurrent chunk requests, as well as configurable maximum retry for each chunk. And then for the server, there is free query method and admin endpoint for management on the fly, and also support opening and closing allocations through a CLI. Yes, multi-threaded downloading. One of the concern we have is if it will take up too much RAM for the client. So we should also add a configurable maximum thread to use, maximum workers, something that sort of limits both the server and the downloader. Yeah, so here, there's these are the few features. In the repo, we also have a feature checklist. And yeah, it's open for suggestions. If you have any particular feature requests, you can leave a comment in there. If you have any ideas. Link, okay, let me maybe someone, yes. In that link, inside the docs, there is a inside docs folder, there is a feature checklist, and you can open issues as well. Cool. I'll move on. So now we are going a little bit more into the details of the structure of the service. So the data producers has two components. One is the server and the other is publisher CLI. The server is similar to indexer servers that you would run continuously that has access to the data set, and it will be responsible for managing pricing and payments, as well as serving requests. For the publisher, CLI is something the producers will use to configure which dataset should be available for downloading. And then for the downloader, the download consumer will run the CLI to select which data producers they would like to use. Although later on we should support that automatically. And it is responsible for setting up a payment channel, send chunk macro payments and requests. It will download the request, download the chunks after receiving response from the producer and write it to the local path that it was provided, and also automatically perform incremental verification of the chunks. So I can go into a bit more UI, UX slides. So this is an example of how someone can run the server. They will provide the host, the port, a wallet for receiving payments and managing allocations or registering their URL. They provide an admin endpoint, admin auth token, as well as a free query auth token if they would like to. Also configure what bundles they would like to support. And it's pretty much this exact format. And later on, we will add another level to support specific files they would like to serve. So the server will start by verifying all the local files that gets initialized with. Although there is also the admin endpoint that can be managed to remove or add bundles as the server is running. It exposes a few other endpoints similar to indexer service, such as the status endpoint or the cost endpoint, operator endpoint, stuff like that. Next, there is the publisher. The publisher also run by data producer, or in general, anyone with access to the file. They will be given a read directory and then a name to name the bundle, and then the files that should go inside the bundle, and then the type of the files, a versioning for the bundle, and the description, as well as a indexing network, a chain ID, although I think the chain ID is optional. And there's a few other optional fields like start block and block, chunk size, identifier, or whether it should store the manifest locally. Next, we have the downloader CLI. The downloader will have a write directory and then a manifest, IPFS hash for the manifest they would like to download. And they will also supply a mnemonic for payments, a provider to connect to the blockchain, and an escrow verifier to create a receipt signer with. So I guess we're stressing that the client is responsible for picking an IPFS hash to download. They're responsible for picking the manifest themselves. They're also supposed to provide a write path and maintaining deposits on chain. Okay. I can pause for questions. I think there's been chats going on. I haven't been keeping track. So there isn't a way to unpublish a file because when we're talking about publish, it's posting on IPFS. If there's a IPFS node that is hosting this file, then we can't unpublish it. The way what you can do is to stop serving the file that the manifest is pointing to. And yes, you have to keep publishing new manifests with the block range. And this could be something automatic, like you can have a worker that keep publishing new manifests and adding it to your indexer, I guess, file hosting service. Because we want something a little bit more static at the moment, it would be I guess it wouldn't be a good idea to have one manifest that has changing content inside.
I hope we got 10 minutes left and still quite a lot to get through, so I think we should move on.
Okay, I'll be quicker. So the basic discovery mechanism that we want to achieve. At first, the indexer register their URL to network contract, and then they will post their schema, or as a publisher, they post their schema on IPFS. The Explorer is a front end that will fetch a register URL from network subgraphs. And from the URLs, they will fetch status from the indexer to receive the serving manifests, CIDs. And then using that CID, they will fetch the schema from IPFS with the data from the URL and the status and the schema. They can create a human readable view of what files are available. And then the clients can then use this Explorer to select the manifest. And here is a simplified sequence of the events. So we start off by a graph network. We're referring to everything that contains the contract, the subgraph, and the Explorer. And then we also have the producer and consumer that interacts with any components inside graph network. The producer, again, register their endpoints, and the network query the status. The consumer do deposits to the Express contract and then make specific queries for a file. The graph network do indexer selection and tells the consumer what URLs will support their specific file queries. And then the consumer will send chunk paid requests to the producer. The producer will verify the receipt or they will reject. And then they respond with the chunk data that were specified in the request, and then the consumer will then do verification to hashing the received data. At the end, whenever the producer is renewing allocation using a service, they can redeem payments from the network. And the network should also be able to provide alternatives or pricing suggestions to the consumer if there isn't a file available for what the consumer desire. And here's a detailed thing. We can skip this because I think everything we talked about so far has in some ways explained what happens in here, and we'll share the slides after so you can take a look if you're interested. Here is the repo and some links. You can schedule a call or write feedbacks. And there are some resources that we used while developing the tool. And that's it. We have some questions ready as well, but I can pause for questions.
Hope, do you want to quickly show, just very quickly, the addendum slide so people know? It might inspire some questions.
Which slide, sorry?
The addendum slides?
I don't really understand, sorry.
Oh, maybe they've been removed. The slides at the end. So on-chain activities, payments, and so on.
So there are these. I can go through. So well, I can start with the questions. Some of the questions we have is, do you think the service would be useful in your indexing operations? By looking at the tool, would you want to utilize it? Do you think file hosting service will help with what we claimed at the beginning, where we would like to reduce the time and resources for indexers and increase efficiency? Do you think it will help or hinder censorship resistance in a way? Any additional features? Any other user stories? And if you're someone who has tried to transfer index data before, what are something you tried, and do you have any advice? As we have some details on-chain activities, the provider, publish. Okay, yeah, so on-chain activities, we have a provider registering indexer URL. This is something indexer service or indexer agent does. Indexers open and closing allocations, also something the indexer agent does. And also collect receipt aggregated vouchers when there is a closed allocation. We are trying to support this without changing indexer agent, but this is mostly supported at the moment. I think open and closing allocation is supported, but we don't have registering indexer URL or collecting vouchers. And then the consumer, the only on-chain activities they would need to have is making direct escrow deposits to indexers. Otherwise, when there is a conflict, we also should support dispute or withdrawing deposits.
Hope, I'm curious about you said that collecting receipts and aggregating vouchers was not supported. Wouldn't that be the same as existing process for aggregating vouchers? Just it would be maybe from a specific gateway for file services, or is this avoiding the gateway completely? This is just peer-to-peer.
This is trying to avoid the gateway, but I think if we are running indexer agent, I guess because the escrow contract doesn't consider like data service to be different from each other, so perhaps it's already supported if we're running indexer agent alongside with the same database for receipts and vouchers. I guess
I see. Yeah, so you basically like collect your own receipts and then aggregate your vouchers on your own system instead of having a separate system for that.
Yes.
Yeah. Cool.
Cool. Yeah, so then the payments, the downloaders are, I guess we talked about this already, that the downloader should have escrow, sufficient escrow balances. They can provide an allow list of indexers. This is more direct rather than going through a gateway or just going through a gateway. There's also the explanation for micropayments. We are trying to make the chunks as small as possible or a reasonable size so that the payment that comes with the chunk is small enough to be negligible risk that you wouldn't need to open a dispute for. And then server are responsible for validating the receipts and aggregating the voucher. This is something when we port our file hosting server to Indexer RS, they should be automatically supported. And also, Ford mentioned, if we are using Indexer agent, the server should be able to redeem voucher at the end of allocation and receive payments. I don't have this ready, so I'm gonna skip this. We also have some known risk and limitations. But I won't talk about them in detail. If there's questions, we can dive into it. And also alternative considerations rather than HTTPS is IPFS with encryption and torrent files with added payments. Okay, I think I'm time. So if there are questions, please shoot them. I will stop sharing now.
We are indeed at time. Thank you so much, Hope, and the rest of the GraphOps team for sharing all of that there. As Pili has shared, we've got some links in here for you guys to provide feedback and also to schedule a call if you want to get more information. Just a final thing before we head off, as always, we're going to give you some POAPs. And the good news is, last time I checked, last week, I believe we didn't have to do any sort of puzzle to get the POAPs. So today's word, oh, there we go. Pili's already on it. Open data. I was about to paste it and she already beat me to it. Thank you very much. So open data, feel free to pop that into your app and get the POAP. Yeah, special thank you to each and every one of the GraphOps team who made it today and shared the information. And thank you to each and every one of you who have showed up today and listened to that. So yeah, links are in the chat. Yeah, that's what we have for today. Thank you so much, and we'll see you all again same time next week for some more exciting content. Take care, everyone. Have a wonderful rest of your day. Bye bye.